All right, this is a continuation of lesson 4.6 on equilateral and isosceles triangles. The first video was on isosceles triangles, and this part 2 will focus on equilateral. So an equilateral triangle is a triangle with 3 sides that all have equal measure. And as we just talked about in the isosceles video, there's a relationship between the side of a triangle and the angle across from it, right? So for all of the sides that are congruent in a triangle, all of the angles across from those sides will have to be congruent as well. So if all 3 sides are congruent, that means all 3 angles are going to be congruent, right? And if we take the sum of all angles of a triangle, 180 degrees, and we divide it evenly by 3, because they're all the same, that means all of our angles will be 60 degrees. So basically, an equilateral triangle is also an equiangular triangle, right? When all 3 sides are congruent, that means at the same time, all 3 angles are congruent as well. So that's what we want to remember about equilateral triangles. Each angle of an equilateral triangle is 60 degrees, and a triangle is equilateral if and only if it's equiangular. So they have to be both at the same time. They can't be one and not the other. All right? So we've got a little example proof here, and I left it written out instead of doing it myself. Here's the picture, if you can kind of see that. Okay, so we've got this triangle here. Here, I'll focus in on a second. We've got this triangle right here. It is an equilateral triangle. It tells us that in the given. Angles 1 and 2 here. PQ is parallel to BC. So that's what we know. So here in our proof, we'll read through it. It doesn't actually tell us the proof in the given, but since it's already written out for us, we know what the given is. So in line 1, as our given, triangle ABC is equilateral, and PQ is parallel to BC. So that's what we already kind of knew. These 2 lines are parallel. All 3 sides are congruent. If all 3 sides are congruent, then we know all 3 angles have to be congruent as well, right? Because that's the whole idea behind an equilateral triangle, definition of an equilateral triangle. So in line 2, they said, or we can say, that the measure of angle A is equal to the measure of angle B, which is also the same as the measure of angle C, and all of those are 60. So each of our angles, A, B, and C, are 60 degrees. Each angle of an equilateral triangle measures 60 degrees. That was our little rule we just wrote up here. It's not a postulate or a theorem. It's kind of a definition, more or less. So they just wrote it out. If you wrote definition of equilateral triangle, I would accept that as well. That's perfectly fine. Equal triangle, something like that. That works as well, okay? So then in the next line, we said angle 1 is congruent to angle B, and angle 2 is congruent to angle C. If parallel lines, then the angle, corresponding angles are congruent. So here, if I know B and C are congruent, right? Well, if this PQ is parallel to BC, and this is my transversal, then angle 1, I'll do it in purple here, is going to be the same size as angle B because they're corresponding angles. Same thing with angle 2. Angle 2 is going to be the same size as angle C down here, right? Because they're corresponding. So if these 3 angles are all the same, this is an equilateral triangle. These 3 angles we just showed are also the same, so that means triangle APQ, or however you want to name that, must also be equilateral. This short side here is the same size as this short side, which is the same size as this short side. This entire long side is the same as this long side, is the same as this long side, since all of our angles here are 60 degrees. So continuing on with the proof. Line 4, measure of angle 1 equals 60, measure of angle 2 equals 60. They just combined these 2 steps to get this step down here. Right? They put these 2 together, and that's substitution. So wherever it said angles 1 and B are congruent, we set up here that angle B is equal to 60, so then I can say angle 1 is equal to 60. I just use substitution. Same thing with angle 2 and angle C. Angle C is 60. It just substituted. Okay, so once I say that angle 1 and 2 are 60 degrees, I already said that top angle is 60. Now I basically said all 3 angles are 60. So in line 5 here, the last line, APQ, that smaller triangle up here, is equilateral. If a triangle is equiangular, then it is equilateral. Again, definition of equilateral triangles. If it's equiangular, it's equilateral, right? Same thing. So basically the given here was line 1. What we had to prove was down here in the last line, and these were the logical steps to get there. Okay, let's do a little bit of algebra with equiangular or equilateral triangles. Find the value of each variable. So here, I'll zoom in a little bit. Excuse me, these awful allergies. This is like the worst time of year to have allergies, seriously. The worst time to have allergies with COVID. Okay, so here all 3 sides are marked congruent. That means all 3 angles are also congruent, so they're all 6x. And we're solving for the variable here, x, so I know 6x plus 6x plus 6x is all going to add up to 180, right? You could also just say, if I know all of these are the same, I know each angle is equal to 60 degrees, so I could just set 6x equal to 60. Get the same answer at the end, right? And if I solve for x here, divide both sides by 6, and I get x equals 10. If I had done it this top way, 3 times 6x is 18x. Divide both sides by 18, and x equals 10 as well. Okay, number 6. I've got all 3 angles marked congruent, so that means this is equilateral, equiangular, which means all 3 sides are congruent. Now, I don't need to know what this side is. I know it's the same value as these two. All I'm doing is solving for x, so I'm going to set them equal to each other. 6x minus 5 equals 5x. Subtract 5x from both sides of my equal sign, and add 5 to both sides. And be careful to read the directions. Here it just said to solve for each variable. We have done it. Sometimes it'll say find the measure of the missing angle or something, and you'll have to find the variable and then go back and plug it in. But here we don't have to do that. All right, and then third, number 7, we've got this one and a proof. 60 degrees here. These 2 angles are congruent, so if these are congruent, that means the angles across from them are congruent. If this guy is 60 and all 3 add up to 180, then these 2 left over have to add up to 120, right? And if we divide them by 2, that means each of them is going to be 60 degrees. Okay, so now all 3 angles are 60. That means this is equilateral, so all of the sides are congruent. And so I set these equal to each other. 3x plus 8 equals 4x minus 4. Subtract 3x from both sides of my equal sign. Add 4 to both sides, and I get x equals 12. A lot of x equals 12s in today's answers. All right. And then we've got a lovely proof here. All right, number 8, we have a proof. Write a 2-column proof here. So we're gonna have our statements and our reasons. There's actually, this is a good example of a proof for me to do with you. It's super frustrating because you have options, right? This is gonna show you one of the reasons why people get frustrated with proofs, because there's not just one correct answer and it gets really confusing, right? But this one isn't too confusing. We'll do it together. All right. So line 1, we always write the given. ABC is equilateral. Triangle ABC is, I'll just put equal. And angle 1 and angle 2 are congruent. And that's our given. If you hear the edger outside, somebody's doing yard work outside. So we can mark this guy congruent to this guy. And we know that all 3 sides are congruent, right? In line 2, I can say that because this is an equilateral triangle, I can say angles A and C are congruent. I'm gonna do it in a different color here. So in line 2, I can say angle A is congruent to angle C, right? Definition of equilateral triangles. If a triangle is equilateral, then all the angles equal 60 degrees. Triangle is equilateral, then it's equiangular. Then all angles equal 60 degrees. So all the angles are the same as well. I could have just said it's equiangular. All the angles are the same. So by definition, angles A, B, and C all have to be 60 degrees, but we know they're both equal. And we know this guy and this guy are each 60 degrees. Okay, so what else can I say about this, right? I'm trying to prove that this angle right here, it looks like a 90, is congruent to this angle right here that's a 90, okay? There's nothing here that it tells me that I can just say that those are congruent. I don't know that for a fact, right? But what I can do is prove that this triangle is congruent to this triangle. And once I prove that I have two congruent triangles, and these angles right here in each triangle are corresponding, then I can say corresponding parts of congruent triangles are congruent, right? Anytime I name a triangle congruent, I can name any part of those triangles after I say the triangles are congruent. I can name any parts of them congruent because of CP/CTC. So my goal here is to first prove that the two triangles are congruent. So I've got two congruency statements. Angles 1 and 2 are congruent. A and C are congruent. The next part is the third thing that I can prove. Now there's actually two options here. So I'm gonna list one option. It does not matter which one you do. I'll show you the difference, okay? I can either say DB is congruent to itself, right? That's kind of where my brain jumps automatically. DB is used in both triangles, so I'm gonna say DB is congruent to DB. And of course, the reason is because that's reflexive. Another thing that I could say here in step 3, I can't say both, I don't need both, but an option, I'll put or for 3. I know this is an equilateral triangle, so I also know that AB is congruent to BC because all 3 sides are congruent, right? So I know that DB is congruent to itself. I also know that AB is congruent to BC. So I'm going to say AB congruent to BC. Why wouldn't we just say both? Why wouldn't I, right? Like the more the merrier. Because I don't need to. I'm using my shortcuts. I'm either going to use SSS, ASA, AAS, or SAS. And with those, I don't need to prove that 2 sides and 2 angles are congruent. I've got my 2 angles. I only need one more piece. So I'm either going to say DB is congruent to itself, or I'm going to say AB is congruent to BC. If I say AB is congruent to BC, then the reason is because this is an equilateral triangle. So definition of equilateral triangle, right? Okay, so then the next step, whichever one you use for step 3, doesn't matter. Next step 4, I can say that my triangles are congruent. So triangle ADB is congruent to triangle CDB. And why? What do I have proof congruent? Well, if you went with this red way here, we said these 2 angles and this side right here, this non-included side, are congruent, right? So when you have 2 angles and a side that's congruent, but it's not the side connecting the 2 angles, it's different. This is angle, angle, side, angle, angle, side. The side is not between the 2 angles, so we don't put the S between the 2 A's. So I know my triangles are congruent with that reason because of angle, angle, side. Excuse me. If you had used this second line here, if you had said this guy is congruent to this guy, then that would be angle, side, angle, right? This angle, this side, this angle is congruent to this angle, this side, this angle. So then I could say my triangles are congruent because of angle, side, angle. Or angle, side, angle. So you had choices there. You could have just done the red, or for number 3, you could have taken that out and just done the purple, right? And if you'd done the purple, then instead of using AAS to prove my triangle is congruent, it would have been ASA, because the side that we proved congruent changed, okay? But regardless, whatever you did for step 4, then we had step 5. I'll do that in a different color. And step 5 is the one I want you guys to remember. Once we prove triangles are congruent, let me highlight that. That's kind of our like end all be all. That's our goal for everything, is to prove triangles congruent. When we're talking about triangles, we want to prove them congruent, right? Once we do that step, anything we say after that, like here, our prove is to say these angles are congruent. This guy, this little angle, is congruent to this guy, this little angle. These 2 angles are congruent. Anything we say after we said triangles are congruent is because of CP/CTC. So angle ADB is congruent to angle CDB. Oops, I just don't think a D. Right? Of course it is. If everything about my triangles are congruent, then these corresponding angles are congruent because corresponding parts of congruent triangles are congruent. I think I keep saying angles and I mean triangles. Right? So once we get here, normally we stop here. Normally the goal is to prove two triangles are congruent. If it's a special case where that's not what we're proving, then first we do still have to prove the triangles are congruent, and then anything after that that we say is always because of CPCTC, if that makes sense. I hope that does. I don't mean to beat a dead horse. I just want you guys to get it. Okay? If you have any questions on equilateral or isosceles triangles, let me know.